All right, guys. Hey, good morning. It should be pretty fast today, so let's get into this. Today we're going to talk about finding values from function graphs. These are still the same graphs, you know. These are still XY coordinate graphs. These are still these guys right here, okay? The difference is just pretty much some of the vocabulary we're going to be able to use. So they're either going to give you X values and they're going to want Y values, or they're going to give you Y values and they're going to want the X values. The only difference is some of the vocabulary we're going to use to describe them. So let's talk about a couple different things we can do. Now we know, we should, I mean, I hope we all know that it can be X and Y, right? So again, we're trying not to totally move away from that notation because it does have its time and its place. But when we're talking about functions, we won't say X and Y anymore. We'll say X and an f of X. And I do want to just note, it doesn't have to be X and f of X. It could be something like G of X, H of X. Usually if we have more than one, we just kind of go through the alphabet. We just skip over I. So it could be something else like this. So these are just different ways to write Y's, right? And it doesn't have to be X. So say we were graphing the height of something. I threw a ball in the air or something like that, right? Like I threw a football or something like that. And we wanted to graph something. It might be height as a function of time, right? As time goes by, you know, I threw the ball, it went up, and then eventually, after a few seconds, the ball came back down. So don't get so locked in on X and Y. They can be other things. But for today, we just want to make sure we can interpret it from a graph. X, Y, X, or f of X. So we could say something like this. We could say t, and then we could say height as a function of time. Okay, but these are all just y. These are different ways to write y. Okay, we could also say these are inputs and output. Okay, I should actually take an English class and use singular there because we're just talking about x's and y's. So it could be an input and an output. And the last thing we talked about, if it's a set for a whole bunch of numbers, we can call it the domain and the range. So since we're going to be talking about individual points today, we won't be talking about these. All right. Just a couple things to note. We did say for a function, for every one number I put in, either I could have no numbers come out or one number come out. So if I am given a situation, I'll try and draw this on here. It's probably not going to go very well. Like this. Right, and we have these 2 points right here, right? And it said, what was that? 1, 2, 3, 4, 5, 6. When is g of x equal to 6? These are the only ones you really are going to have to look out for real today. This really means y is equal to 6. So when is y equal to 6? Well, it happens here. It happens when happens twice, right? It happens when x is equal to 1, 2, 3, 4, 5. So when x is equal to negative 5, and when x is equal to 2. So whatever this function is, when I plug in negative 5 and I plug in 2, I get out 6. So again, whenever you see something like this, g of x, the x hasn't changed. The x is still x. The g of x is what you're going to look, and that's where you're going to think about what we used to call the y value. So let's take a look at a few problems, and then that should be it for today. I want to keep it short because then you guys maybe will watch this. Okay? So it says plot the point on this function with an x value of 9. So x is equal to 9, so we're going over 9. So what's the point? It's going to be right here. What's the y value at that point? Well, it's 6. Again, this is nothing earth-shattering. You guys should be able to do that without much of a problem. Plot the point on this function with a y value of 9. Okay, so this time they want a y value of 9. So the y value of 9 is here. And the corresponding x value would be 7. Right. Nothing crazy there. Plot the point on this with an x value of 0. So when I plug in 0, what do I get out? Well, it looks like I get out negative 1. So what's the y value at that point? Negative 1. I plugged in 0. What came out? Negative 1. plot the 2 points of this function with y values of 7. So let's go up to 7, and again, it's going to happen twice, once there, and once there. So it's like negative 10 and positive 10. So what are the x values of these points? Negative 10 and positive 10. Okay, again, x value of negative 2. So if I plug in negative 2, what do I get out? 3. Okay, I'll skip a level here. There's a bunch of levels. What is the output of this function when the input is 3? So again, we know that this input is x and this output is y. So when the input is 3, when x is 3, our output is negative 4. Okay. What inputs of this function have an output of 4? Again, your output meaning y. So when is y 4? So it looks like here, and going straight across here. So it looks like negative 10 and negative 1. Okay. Again, when is your output negative 7? Your output negative 7 only occurs once here, and that's going to be at your minimum, which is negative 8. Okay. Again, use this graph of g to find the solution of g of x. Remember, when we see g of x, that means when does y? This is y. So when does y equal negative 10? Y is equal to negative 10 right here, right? When x is equal to 9. They're okay with 9. I would really rather see x is equal to 9, but whatever. Use this graph of g to find the solutions of g of x. So again, g of x is y, right? So again, 1 is equal to 3. It happens here at 7, and it happens again at 10. And that's pretty much it, guys. I don't think there's much more to this than that. Again, f of negative 10. So when is it f of negative 10? So when is y equal to negative 10? Ooh. Oh, I'm sorry. Use the graph f to find f of negative 10. In other words, when I plug in when when the function is evaluated at negative 10. Okay, so they don't want this. They want you to find this. So when I have negative 10, the answer is going to be negative 4. Okay, and that's pretty much all it is. There were a couple of different functions, but other than that, you guys should be fine. So give it a try, and let me know if you guys have any questions.